Alright guys, welcome back. This is 2014, question number 4, D. Someone asked for D. So I'm assuming you guys already did A, B, and C. You read through the problems and everything. So I set up question number 4 right here on the right side. Feel free to pause it and figure out what I did here. But I'll do a quick explanation. Um, Train B is traveling north from original station. I call it OS. Train A goes back and forth, whatever. Okay, so I call this X and this is Y. And if the train B is right here, train A is here, then Z would represent your distance between those two trains. So they gave you the velocity of B. They gave you at time t, at time 2, what is that, 2, what, oh, minutes. At 2 minutes, y equals 400, so the train is 400 meters away from the original station. So this will be 400 right here. Our goal is to find, or your goal is to find the change, the rate and change of the distance, the rate in which the distance between the trains are changing when time equals to 2. Okay? So the relationship between y, x, and z, if you could see here, this is a right triangle. We're going to use Pythagorean's theorem. So I have, let's go with z squared. Let me move up a little bit. Equals to x squared plus y squared. Okay? And then if I take the derivative, I get 2z dz dt equal to 2x dx dt, and then plus 2y dy dt. And I could immediately cancel all my 2's out, right? Divide everything by 2. Those are going to be gone. And then also, at time equals to 2, I know that y equals to 400, right? I also know, according to my table, right, that x at time 2 equals to what? Let's see. I'm sorry, not the table, but in letter C, it says at time t equals 2, train's A position is 300 meters, so we're going to use that for my x, 300, and then Pythagorean's theorem, or the second Pythagorean triple, z equals to 500. Okay? I'm looking for dz dt, right? The rate dx dt at 2, that's given to me at, that's the table, right? At t equals 2, v of a of t equals to 100. Remember, the table is the train A's velocity, right, which is the derivative of position, right? So dx dt would be 100 at 2. So I'm going to write that out. So, whoops, I have dx dt equals 100. We're looking for dz dt. dy dt at 2 is simply vb of 2. Inputting 2 into my green equation here. And I think you'll get a value of, what, 125? Okay, cool. So now inputting all this into this equation, I have z, which is 500, times dz dt, which is what we're looking for, equals to x, which is 300, times dx dt, which is 100, plus y, which is 400, right, times dy dt, which I found was 125. And then we can just solve for dz dt, which I believe is 160 meters per minute. Okay, that's it for now, guys. See you later.